Hello class, and welcome back to another video lesson. What we're going to be talking about in this video is just looking at an equation or looking at a relation and just determining is it a function or not. So this is an important skill. We're going to have to do it on accelerated math for one of the objectives today. We're also going to see it on a test coming up later on in this chapter. So what are our hints for determining if a relation or if an equation is a function or not? Hopefully you remember that if we see a graph, it's very easy to tell if it's a function just by using the vertical line test. Vertical line test. The other hint that we can use, which helps us a lot when it comes to relations, is going to be the x's cannot repeat. However, the y's can repeat. So make sure you keep that in mind. If you see a y come up more than once, that's okay. It could still be a function. But if you ever see an x value that comes up more than once, you know for certain right then and there that is not a function. So keep that in mind. With that being said, oftentimes it makes sense to go through 1, 2, 3, 4, 5, and 6, but it also makes sense to kind of do maybe some of the easier ones and save the harder ones till last. So let's do number 3 and number 6 after saying that strategy, just because now it should probably be pretty simple. We know that the x's cannot repeat, and if they do not, then we know it's a function. So we have our x's of 3, 2, and 7. Do any of those x values repeat themselves? Obviously not, right? So if the x's do not repeat, then we would say, yes, this is a function. Number 3 would be a yes. Kind of to piggyback off of that, on our last video lesson, if it's 1-to-1, the x's and the y's cannot repeat. Do any of the y's repeat themselves? Yes, they do. Here's a 5 and here's a 5. So I want to be very clear here, class. Yes, this is a function. Make sure you get that. It is a function. However, it is not 1-to-1. And that wasn't part of the question in this example problem, so you don't have to write that. I just want to be very clear on the difference between a function and a 1-to-1 function. Going on to number 6. Do any of the x's repeat themselves? Here's a 3, here's a -2, and here's a 3. Well, because my x is repeated, that cannot happen in a function. So is number 6 a function? Hopefully you would say, no, it is not a function. Number 6 is no. All right, 2 done, 4 left to go. In my opinion, I would say maybe number 5 is the next easiest. If you look at 5, it's the equation y equals 2x plus 3. Y equals 2x plus 3. Does this look familiar to anybody? Y equals mx plus b. I'm sure you guys have dealt with that equation so many times before, especially in intermediate algebra, even a little bit in chapter 3 of geometry. You guys know that this is a straight line. A line has y equals mx plus b form. We're going to get into that more in detail in the next couple video lessons. But you guys know that the b is going to be the y-intercept, and the m is the slope. So if we were to put this on graph paper, we would say that it crosses my y-axis at a positive 3, and it has a rise of 2 and a run of 1 for a slope, because my slope is 2/1. So here's my line. It goes just like this. So now I guess the question remains, is this a function? Does it pass the vertical line test? Let's just take out our straight edge here. Does it pass the vertical line test? Oopsie. All right. It touches my blue line only once, only once, only once, only once, only once, and it will continue going that forever to the right and forever to the left. So as we can see, a line y equals mx plus b form is a function. So you would say yes for this one. Any line, whenever you see it in y equals mx plus b form, it is always, always, always a function. So number 5 is yes. All right. We have 1, 2, and 4 left. Let's maybe do number 4. This one might not be quite as familiar. Some of you might remember it from geometry. If you don't remember it, don't feel bad. It was a long time ago, and we always need reminders. So if we have x squared plus y squared equals 7, I'm curious to see if some of you are picking this one out yet. What type of a graph does this one look like? Let's see if anyone remembers this formula from geometry. It is x minus h, that quantity squared, plus y minus k, that quantity squared, equals r squared. This, class, is the formula for a circle. The center of our circle is at hk, and the radius is the square root of this number, because r squared goes there. So as you can see, this one is kind of like saying x minus 0 quantity squared plus y minus 0 quantity squared. That equals r squared, which is 7. So what type of a graph does number 4 look like? Number 4 is actually a circle. It has its center at 0, 0, and then the radius is the square root of 7. So more than 2 units, but less than 3 units. So if we look at this, does this one pass the vertical line test? Instinctively, hopefully you know the answer right away without even using this line. It can only touch our graph once and only once. How many times does it touch right here? It touches once there and once there. So this one, a circle, is not a function. Same thing if we move it over, touches once here, touches once here. So a circle is not a function. You would say no for this one. So if you ever see an x squared and a y squared in the exact same equation, that is most oftentimes a circle. And a circle is never a function because it does not pass the vertical line test. All right, we got numbers 1 and numbers 2 left. These ones are probably going to be the most tricky as of right now. I will try to explain them as best as possible. It might take some review on your guys' part because I know that you've done it before, but like I said with number 4, it was quite a while ago, and it's always good to have reminders. So if we have, for number 2, y equals 2x squared minus 4. When we see something that looks like this, a y equals an x squared term, whenever y is raised to the first power and the x is raised to the second power, what we call this is a parabola. We're going to get more into that in chapter 6. In fact, we're going to go very, very detailed in chapter 6. So this is just kind of a preliminary lesson to kind of get you thinking along those lines. So if y equals x squared, it's a parabola, and hopefully you guys remember what a parabola looks like from intermediate algebra. On our graph paper, a parabola looks like this. It's more U-shaped. So I ask you, is a U-shaped graph a function? Going from left to right, it touches only once, only once, only once, only once, only once, only once, only once. And these lines mean that it continues to go up and to the right forever and ever and ever and ever, and up and to the left forever and ever and ever and ever. So you guys know that it will continue going up and to the right, so it will continue touching only once, only once, only once, only once, as it goes up and to the left, only once, only once, only once, only once. So number 2, parabolas are one-to-one functions. You would say yes for this one. This one is a function. Now, notice how that is when a y value equals an x squared value. We can kind of ignore these ones right now. For all that we care right now is that we know that it is a U-shaped parabola. It could be right here. It could be way over here. It could be skinnier. It could be wider. But all you care about right now is that it's U-shaped, which means that it is a function. Now, number one, in my opinion, is the most difficult one because you have to remember the different relationships with parabolas. If it's y equals x squared, it's U-shaped this way. However, on number one, we have an x equaling a y squared. If x equals y squared, that parabola is now turned 90 degrees. So it looks more like this U-shaped parabola. And it could be anywhere on the xy axis. So if we see this one, probably should have drawn my coordinate plane in a different color. So there's my xy coordinate plane. And we have this U-shaped parabola that goes to the side. So now if we take this vertical line, as you can see, this one is not a function because it touches once right here and it touches once right here. If ever it touches more than once, it is not a function. So for a sideways parabola, this one would be a no. So those are the 6 problems. If we were to recap this here, we would say that if y is raised to the first power and x is raised to the first power like number 5 is, it is a completely straight line. And straight lines are always functions. For number 4, if your x squared, or if your x is squared and your y is squared, we know that this is a circle. And a circle is not a function. So now we go on to this one. If y equals an x squared, it doesn't matter what these numbers are. We could have y equals 13x squared minus 17. It doesn't matter what these numbers are as long as you see a y raised to the first power and an x raised to the second power. This is always going to be a parabola that is U-shaped. It could be an upside down U-shape, but then the same thing applies. It would still be a function, yes. And then for number 1, if it's the opposite order, meaning x is raised to the first and y is raised to the second, that U-shape rotates 90 degrees, which means that the U-shape is now going this way. And this one does not pass the vertical line test. So when it's a y equals an x squared, it is not a function. Whew! And number 3, number 5, you can use these 2 properties that we talked about up here. So now last thing, is a parabola a one-to-one function? Remember what a parabola is? It is U-shaped. So here is my parabola. Let's say it's maybe right over here. If that's my parabola, we know that it is a function because it passes the vertical line test. So it touches this blue line once, and only once, only once, only once, only once. So we know that it is a function, but this question asks, is it one-to-one? What do we have to do if it's one-to-one? It has to pass the vertical as well as the horizontal. Touches twice right there. So in our answer to our question, no, it is not a one-to-one function. The reason for that is because it wouldn't pass the horizontal line test. So that is an important skill. Let me know if you have any questions with it as you're doing your assignment for today. I wouldn't say it's something that's all that difficult. However, there are a lot of rules that we have to memorize. So be sure to let me know if you want any more practice on that, and I could help you out to give you a further understanding.